Now, let's look at a couple more example problems for determining if lines are parallel, perpendicular, or neither. So for this question, we're told that one line passes through the points 1, 9 and 4, negative 9. Another line passes through the points 6, 5 and 8, negative 5. And we just need to figure out, are they parallel, perpendicular, or neither? And to do this, we need to understand the slopes of these lines. Since if we call the slope of the line through these points m1, and we call the slope of the line through these points m2, then looking at the relationship, we can figure out if they're parallel or perpendicular, or neither of them. So if they're parallel, we can say that m1 and m2 are equal. But if they're perpendicular, then the product of m1 and m2 would be equal to negative 1. So it's a little bit trickier with perpendicular lines, but they would hold this relationship, or they are negative reciprocals of each other. So you would take m1, you flip it over and make it negative to be the slope of m2. So let's figure out the slope in each of these. And we know the slope is defined as how much the line rises divided by how much it runs. Or it's defined as how much the y values change divided by how much the x values change. And we usually call slope the letter m. And for these blue points here, to find m1, we could also use the formula where the change in y values, that's y2 minus y1 over x2 minus x1 for the change in the x values. And this comes from the points x1, y1, and x2, y2. So from two general points, we can just plug them into this formula. And let's do that for this one. We can call this y2 and x2. This could be y1 and x1. So plugging those in, the slope of the blue line, which we called m1, is the difference in the y values, minus 9 minus 9, so y2 minus y1 minus 9 minus 9, and x2 minus x1 for minus 1 in the denominator, so that's minus 18 over 3, which is negative 6. And we'll need to do the same thing with m2, so our green line here. And we can label these again. This we can call y2, which makes this x2. This can be y1, and this is x1. Now plugging all of these in, we take y2 and subtract y1, minus 5 minus 5. And we take x2 and subtract x1, 8 minus 6. And this is negative 10, and this is 2, so we get negative 5. And we can see right away that they're not the same. So they're not going to be parallel. And if we multiply them together, notice we get positive 30. So they're not perpendicular, which means that in this case, they're neither. So these lines do not have either of these special relationships. And let's do one more of these problems. And for this one, we are given the graph of the lines. And the process is the same. We need to find the slopes of each of these lines. So let's do that. We can start with this green line here. And to find its slope, we just need to figure out how much it rises and divide by how much it runs. And we can call that slope m1. And notice for the x values that it starts at negative 1 and goes to 7. So if we count 1 to the y-axis and 7 more to get to this point here, this would be a length of 8. And the y values start at 9 and end up at 3. So they go down 6. And from here, we can figure out the slope of n1. The rise is negative 6. The run is positive 8. And let's work on the blue line now. So we'll again make a triangle. Now with this triangle, we can figure out the run and the rise. Notice that we're at negative 8 for the furthest left x value, and we go all the way to 1. So 8 takes us to the y-axis, and one more makes this 9. And notice for the y values that we're at -8, and we go up to 4. So it takes 8 to get to the x-axis, and then 4 more to get to the point, so that's 12. And we can call this slope m2. So m2, the rise is 12, and the run is 9. Now let's simplify each of these. These can both be divided by 2. So you get -3/4. And these can each be divided by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. And notice that if we take one of the slopes, we flip it over and make it negative, we get the other one. And this is the property of perpendicular lines. Also notice that if we multiply the two slopes together, we should get back -1 if they're perpendicular. So 4/3 multiplied by -3/4. Multiplying straight across, we get 4 times -3, that's -12. 3 times 4, that's 12. 12 divided by 12 is 1, and so we have the opposite of that. So we get -1, which confirms that these are perpendicular. So our final answer here is that the two lines form a right angle between each other. They are perpendicular lines.